Hello everyone, I am Someshra Chandapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So today in this class we will discuss about point of contraflexure or point of inflection. So point of contraflexure generally occurs in case of overhanging beam. So when in case of overhanging beam, the supports we will have movement. So at the end of support we will have movement, then in that cases point of contraflexure or inflection will occur. The second thing is if bending moment changes its sign from positive to negative or negative to positive, then that will be termed as point of contraflexure or point of inflection. So at that point when bending moment changes its sign or bending moment will be 0, then that will be your point of contraflexure. Next thing is when bending moment changes its sign from sagging to hogging or hogging to sagging, vice versa, that will be your point of contraflexure or point of inflection. So here is the example that you have BC simply supported beam and we have one UDL over the overhanging beam. So first thing is here you have BC and overhanging part is your AD parts. So you can see if we draw the bending moment diagram of it, we will have this E point after B. And here you can see this bending moment changes its sign from negative to positive. Okay. And also after this F point, we will have seen that after this point, here positive to negative sign changes. So these 2 points will be termed as point of contraflexure or point of inflection. Okay. If we solve a numerical on basis of this, we will know better. So here I have one numerical that in this case you can see AB is your simply supported beam and CE part is your overhanging. So here we have load about 15 kilonewton and 25 kilonewton, and at the midpoint we will have 140 kilonewton load. So first thing we need to do is calculation of reaction forces. So first we will calculate reaction. We know that reaction forces will be appear in case of support. So here we will generate one RA and reaction B will be here. So RA plus RB will be this 40 plus 15 plus 25. So RA plus RB going to be 80 kilonewton. Okay. Now let's take moment about A. So we will have movement about A point. Okay. So here you can see this 25 kilonewton will be multiplied with the distance. 25 will be negative sign. 25 will be multiplied with 6.5 meter. Then plus RB into 5. 25 will be multiplied with this whole distance and RB into 5 and minus 40 into 2.5, then plus 15 into 2 is equals to 0. So here you have, let's use the calculator. First thing we have 25 into 6.5, that is 162.5 plus 5 RB minus 40 into 2.5 . Here you have 100 again plus 30 equals to 0. So here you will have minus 162.5 minus 100 plus 30. So you can write that 5 RB equals to 232.5. RB will be 232.5 divided by 5. 46.5. We know that RA plus RB is 80 kilonewton. So RA will be 80 minus 46.5. That is your 33.5 kilo Newton. Okay. Now we have the reaction force, that is RA and RB. Put it here. So we have the RA and RB value. Okay. Now our work is to find out forces. So let's write it here. 33.5 kilonewton and RB is your 46.5 kilonewton. Okay. Now our work is to find out all the forces. So here you can see the forces will be generated at point A, B, C, D and E. Our work is to find out forces first from right hand side. So let's calculate forces. Now we will calculate shear forces. So first go for calculation of we will calculate from point E. So first at point E, shear force at E, it will be what? 25 kilonewton and it is in positive sign. Next is your shear force at point B. So 25 minus 46.5. Here this will be minus 21.5 kilonewton. Shear force at point D. It will be minus 21.5 plus 40 plus 40. We will have 18.5 and that will be in positive sign. Okay. Next is your shear force at point A. RA is your 33.5. So 18.5 minus 33.5, that is 18.5 minus 33.5. This will be minus 15. And in case of C, same will be minus 15 kilonewton. Okay. So you have all the shear forces here. We have the shear force. Now we will calculate bending moment. So bending moment, also we will calculate bending moment from right hand side. So at point E it will be, we will take bending moment at point E. So it will be minus of 25 will be multiplied with what? 0. So this will be your 0 kilonewton into meter. Next is your bending moment at point B. Similarly, minus 25 multiply with the distance 1.5. Okay. So it will be 25 into 1.5, that is your 37.5 in negative. Next calculation at point what? At point D. Similarly, minus 25 will be multiplied with what? 2.5 plus 1.5. So it will be 4 plus RB. We have RB as 46.5. That will be multiplied with 2.5. So it will be minus of 100 plus 46.5 into 2.5. That is 16.25, and your unit is kilonewton into meter. Next, we will calculate bending moment at point A. The same process, minus 25 will be multiplied with the distance, that is 5 plus 1.5. Your 6.5 plus this 46.5 will be multiplied with 5 minus 40 into 2.5. Okay. As we are increasing the length, so this distance will be multiplied. Okay. Here first 1.5, then 1.5 will be added with 2.5. Again this 2.5, like this. So minus of 25 into 6.5 plus 46.5 into 5. Next, minus 40 into 2.5. That is your minus 30 kilonewton into meter. Okay. Now, the last one, that is bending moment at C. So, same like minus 25 into the whole distance, that is 5 plus 2, 7 plus 1.5, 8.5 plus 46.5 into 46.5 will be multiplied with 5 plus 2, 7, minus 40 into 2.5 and 2 meter. So it will be 4 and plus RA. RA is your 33.5. 33.5 will be multiplied with 2 is equal to, so minus 25 into 8.5 plus 46.5 into 7 minus 40 into 4 plus 33.5 into 2. 20. You can cross check it and it will be your, I think it will be getting 0. But you need to cross check it. Okay. So this will be your kilonewton into meter. Minus 25 into 8.5. So 46.5 46.5 will be multiplied with this whole 5 plus 2, again 40 into 2.5, yes, minus 40 into 4.5. So here, okay, again we will solve it like 25 minus of 25 into 8.5 plus 46.5 will be multiplied with 7 minus 40 into 4.5 and plus 33.5 into 2 here. So you need to do it very correctly or else you will have wrong answer. So if we know that these support points bending moment will be always 0, so that I just need to do this because we can correct the whole calculation in case this will be wrong. Okay, if bending moment at these end points will be 0, that does mean we have correct the calculations. Okay, now what we have both the shear force calculation and bending moment calculations. So if you need to just do this screenshot, do this, and now we will draw the what shear force and bending moment diagram. We need to draw the shear force bending moment diagram because now our work is to find out the point of contraflexion. From answers, you can check here. You can check first is your 0. Then we have the answer in negative, that is minus 37.5. Again positive, that is 16.25. From these you can get that our point of contraflexion we already have. But at what point we have the point of contraflexion, we need to calculate that. Okay. So at every point we will have the shear force and bending moment diagram. So now we can draw from this. Okay. So I just roughly doing this. You can use the scale and pencil and other things. Okay. So first is your force at E is 25 kilonewton. So this point you have 25 kilonewton. First at point E. Next is at point B you are having minus 21.5. So this will be your minus 21.5. Again at D you are having what? 18.5 kilonewton. Similarly, now you have minus 15. Here minus 15 kilonewton. Shear force at C also minus 15 kilonewton. Okay, we have the points. You can name it here also like E, B, D, A and C. So our work is just we will join this. This will be look like okay. This E to B is your 25 kilonewton. We will darken this part. Next, from point B, we have minus 21.5 kilonewton. Also, this part We have now at point D, the value is 18.5. Okay. Second, CO force at A you have minus 15 and C you have minus 15. So this. So this whole is your CO force diagram, that is S, F and D. Okay. Now we will draw the BMD. So first we will start from bending moment at E. Let's we have this. First thing is at point E we are having 0 kilonewton in meter. Next at B we are having negative 1, that is minus 37.5. So here minus 37.5 kilonewton into meter. Okay. Then this will be 16.25. 16.25 kilonewton into meter. Okay. Then minus 30 again minus 30 kilonewton into meter, and last is your 0. So this will be look like exactly in this way. Okay. So here this is your E, this is B, D, A and C. So I can say here this darkened part is your bending moment diagram. Okay. This whole dark part is your bending moment diagram. Now let's change the color. Yes. So you can see at this A to B we have 2 points where movement will be 0. First point is this and another one is your here. These 2 points we are having movement as 0. Okay. Also the second part, here movement becomes 0 and you can see bending movement is becoming positive to negative or negative to positive. Here negative to changes its sign from positive, and here positive to it changes its sign to negative. Right. Now also you can see hugging to sagging. These 2 points changing hugging movement to sagging movement. Now we can say we have 2 points of contraflexure, and let's name it as here this to this distance, let's take it as x, and this to this let's take it y. So I can say at A to D distance x we are having 1 point of contraflexure, and from B to D at distance y we are having 1 point of contraflexure. Now at what point or at what distance we are having this, we will calculate. So let's calculate it. So we will calculate point of contraflexure from point A. Let's calculate it. first thing we will do calculation of point of contraflexure from distance from A. Okay. So first we will calculate x. So we know that moment at x is your 0. Okay. So we can also write that moment at x. How to find out moment at x? From this side. So let's take 15 will be multiplied with minus 15. Minus 15 will be multiplied with what? First is 2, then 2 plus x. Okay. And you know array is 33.5 plus 33.5 into x. So it will be minus 30 minus 15x plus 33.5 x equal to 0. We can write it. Next is, let's use the calculator. So plus 33.5 x minus 15 is your 18.5. 18.5 x equal to 30. So x equal to, okay, x will be your 30 by 18.5. That is 1.621. So here this x distance, this to this is your 1.62. 1.62 meter. Yes. We have the x distance as 1.62 meter.